Sweet. Fantastic.
Rommet skal være sprinkla ut mellom hver runde. Kjører antibakke sprinkla.
It's quite heavy and it's quite big and it's okay, but and the heart rate monitor is quite accurate. I compared with the strap-based one, but I'm not sure. Like it looks more like a normal watch, not like a sport watch, and it's not that great for running and things because it's actually quite heavy. But it's really cool. Like the interactivity is nice, and you can load up apps and. All right, we ready to roll. If you can take the floor.
Yeah, I will. So today I'll be presenting Google Cloud and Google Fit, and more specific Google Cloud Storage and Google Cloud Messaging. I'll start with the Google Cloud. So they say that Google Cloud Storage is a powerful, simple, and cost-effective object storing service. The features of it is strong consistency, meaning atomic operations. Either the operation succeeds or they not. You've got something that is called region buckets, and that is storage spaces that is allocated either in the United States, Europe, or Asia. So it means that you can have your storage closest to you. No matter where you are in the world. The other thing is browser downloads and resumable uploads. The last one is very convenient because it means that you can resume your uploads later if your connection is lost or you're doing something else, and you won't have to re-upload the part that you already have uploaded.
Is it the same with Apple or no?
Think of it as RESTful, so.
Right. Yeah.
And you got the object change notification, meaning that you got the two-way communication between your storage and your application. So if anything changes on the server side or storage side, your application may be not notified of it. So the architecture consists of the components project, buckets, objects, and access control lists. So a project is your application, and your application contains buckets, which are your storage, or could be seen as folders. But the thing that separates folders and buckets are that the buckets can't be nested, and the buckets again contains X amounts of objects, and those buckets and objects have their own access control list, which consists of group access or user group and permissions. And the user groups tells which user or which user groups that have access to these buckets and objects, and the permission tells them what kind of permission they have, like read, write, and delete. For tools, they have a Cloud Console, which it's really simple. Some clickable buttons for creating buckets and deleting buckets, creating projects, managing, uploading, downloading objects. I'll demonstrate it later. They have a command line in Python, and they also have a REST API and client libraries. So as I said earlier, the data belongs to a project, and the project contains X amounts of buckets, which again contains X amounts of objects. And the data in a project consists of users, billing APIs, authentication APIs, and monitoring APIs. And those are basically used to manage your project or application. And I said already, buckets can't be nested. And the buckets again may have three one of the three kinds of storage classes. You got standard, durable, reduced availability, and nearline. The standard storage is for what they call hot objects. It's where you want to. It's a kind of storage class where you have objects that you want to access fast and often, like yeah, no, it's yeah, objects you would usually access, like if you got an image service, you have to access your image often. You got durable, reduced availability,
which is my color.
That is when you want more. It's where you have objects that is where it's acceptable to have some latency when you want to access them. That could be user information that you don't want to access that often as hot objects. And we've got this last one is nearline. That is for long-term storage, like archiving documents or legal documents, where usually it takes a few seconds to access them, and you won't access them that often. And they have different kind of pricing, depends on what kind of classes you use for your buckets.
So the standard one is also durable, right? Because it's a little bit more expensive than the durable reduced availability.
Yeah. And again, the buckets may have unlimited objects, where each object can be no bigger than 5 gigabytes. So it's more than enough, I think. And they also have a free plan up to a certain usage. So this is two different kind of diagrams showing where the Google Cloud Storage resides. And for mobile solutions on the Google Cloud Platform, it resides right in this right corner, where it says data from your devices, your big data, your analytics, and yeah, just about everything. It's saved into the Google Cloud storage. That also includes the Google Fit. For dedicated server gaming solution on the Google Cloud Platform, it resides right here. And it's all for that use case, it says game statistics, game saves, and it also queries the big data from the Google Cloud storage. Let's look at a short and simple demo. So this uses a Python API to access it.
Mm-hmm.
So I'll just log in. Give it access to Google Cloud Platform. And it should be logged in now. So this is my example project. It's called Advanced Mobile. So right now it contains no buckets. So we'll just try to make a bucket. Well, how do you
Perfect.
So we'll just create a bucket, make bucket is the command, and you have to tell it to where it's supposed to be. And you give it a name. Pictures. That will create a bucket. And you should see a bucket right here now. There you got funny pictures, and it's the kind of standard class of storage. So this is where you would access hot objects. So we will try to upload some pictures in it. So I have some pictures of flowers. So we'll try to upload those into the bucket. So this will upload every picture inside that folder into the funny pictures order. And then data uploads that. Does not exist, so there's type error. There's another one.
Another typo.
There. It should be applied. 3 and 4. Should be some files. There you have the features. And when you want to delete the folder or the bucket, you have to delete all the objects inside it before you delete the bucket, or else it will get an error message, and the command is just remove. Really. So that was a short demo, just how to use it.
You have some free quota, or do you have to pay for?
No, I'm using a free version now, so it limits your projects up to I think it's 10 gigabytes of data.
Yeah.
And X amounts of projects and buckets, as long as you resize within the 10 gigabytes.
Does it count against your Google Cloud, against your normal drive, Google Drive, or
no, it's
separate?
It's separate.
Yeah,
but they are integrated, so you can access files between them. And it also requires your credit card information when you.
If you exceed, they will just
start charging.
Yeah. The reason behind it is that they want to verify that you're a real user and not some trying to create it. But
yeah,
they say they won't charge you, but I don't know. So that was the Google Cloud Storage. We'll go to Google Cloud Messaging. So the features of it are upstream and downstream messaging, meaning that communication can go both ways. Usually they are downstream, going from the server to the device. But since they've seen the option or the possibility that since they're using downstream, the connection is already open. So why not use upstream too? Then the device can tell the server or notify the user, usually for confirm messages. Things like that. We got cross-platform. It uses the same API for Android, iOS, and Chrome. Chrome is something that has come in the 3.0 Google Cloud Messaging that came early this year. Makes it possible to send notification to your Chrome web browser and vice versa. And we got different kinds of targets. You got single, groups, and subscribing devices. For a single one, that is between the server and the device. You got groups where you may send notification to either a group of devices for a user or a group of users that resides within a group. Or you got subscribing devices, that is users that is subscribed to a kind of topic, or and they say I can send up to 10,000 notifications at once. You got delivery receipt, that is the upstream part. If in your downstream message you set the delivery receipt to true, the device is able to confirm whether the message was received or read or handled in some way. And you got the user notification, the one that we're most known with. So as you would guess, it's asynchronous and bidirectional. It can be used over HTTP or XMPP. The payload of it is JSON, and could be for the downstream it's limited to 2 kilobytes, while the upstream is limited to 4K. The max connection allowed per channel is 100. The standard connection per connection is 100. So you could have a lot of them without being limited. And the messages are guaranteed delivered by either saving them on the server if they're not able to send to the client, or the client can save them locally and resend them when you got connection to the internet or the server. For upstream part, you need acknowledging. That is different from downstream, since downstream is it's registered to the device or the user. So they only use the notification key to push the notification, while the upstream is not device specific. So you have to acknowledge that, or the server have to acknowledge to the device that the message has been received. So this is a simple diagram of how an application may send notification through the Google Cloud Messaging and then to the user's devices. So I'll explain 3 different scenarios where you would use it. So I forgot to have it full screen. So the first one is if you're using the Google Cloud Messaging and you set the short time to live field, that will only send the notification to the currently connected device, meaning that it will die out on the other devices if the user has multiple, if he has a phone or a tablet or a Chrome open on his computer that is idling. And they have something called delay while idle. That meaning the device is not in use. So if you're using the short TLL combined with the delay while idle, that is set to true, the notification will reach all devices, but it will, if it's handled on one of the devices, it will die or go away on the other devices, so you don't have to feel that it's nagging or spamming you. And that is the delay while idle is something that came in the web or the cloud messaging 3.0 this year. And then you got the third one where you use upstream, and that is when the application sends a notification to the Google Cloud Messaging, which again sends it to the user device, and the user device or the user puts it out or handles it in some way. It's able to upstream and message telling that this notification was actually read or handled by the user. So to the Google Fit. That is something very new this year, or they have released it to the public, because earlier it was offered to developers or some developers. So the features of it are a single set of APIs to keep track and manage fitness data. It requires Android 2.3 or API level higher than 9. That is because Google Play Services is only working on those devices. It is cross-platform, meaning you can use Android or iOS. The iOS uses a REST API, while the Android uses native. And it includes wearables, which is Android Wear, like the watch Mario said. It blends data from multiple apps and devices. I'll talk more about later. And to access it, an app may request full access to the user's fitness data through the Google Fitness data. So this is a simple diagram of how the services are offered. This is the mobile device. You got the sensor, you got an app, which talks to the Google Fit APIs, which again talks to the storage. And you got a web interface that is able to talk to it through your REST APIs. So this is the main interfaces. You got the Play API, which scans and claims devices. The thing that they do by claiming devices is meaning that they are only able to access data that is what they call claimed or connected to your phone, so they won't, so that the apps won't continuously receive data from unclaimed devices. And it uses low frequent or low powered Bluetooth. We got a config API, which accesses custom data types and settings. So with Google Fit, you got some predefined data types. You got meals and running and steps and so on. But each app are also able to create their own custom data types, and they have to define them through a schema. But the funny thing about it is they are only limited to the app that is created them, meaning you have to they can only be read by the app that created the custom data types. You got history API. It's for really managing your data, inserting, deleting, and reading data. Recording API enables low power, always on background collection of data. So the recording API is it's the API that actually records the data and saves it on the storage. And then you got a sensors API, which accesses live data, and that doesn't save, but you're able to access the live stream of the sensors. So you're able to update a UI or something with live data. And you got a session API, creating and managing session of a user's activity. So within Google Fit, behind the scenes, a session is an activity that the user has started. It could be running or something, but a session is limited to a different or a set amount or X amount of activities, and it's set in a time frame. So if you went out running, you created one session. If you later went out rowing, you created another session. As I said, it revolves around sessions, and session again have a start time and end time. They got the user file name. They didn't say what that meant, but it also has a description and an activity type and a unique identifier. This unique identifier is later used to query the data or access the session. You could look at a different kind of activity. So they have some predefined activities to make it easier for the apps to access the different kind of data. The list is pretty long, but there is one thing I don't have, and that is weightlifting. Yeah, no, they have it right now.
They have weightlifting.
Yeah, I have now, but it doesn't say
97.
Yeah, it just doesn't have any sub activities within the weightlifting. That was the missing part. Weightlifting.
So you can only pick the ones which are defined.
Yeah, if you want to communicate between apps.
Yeah.
You may define custom activities, but then they're only accessible to your own app.
Yeah, I was on the Google Plus channel for the Google Fit, and they were saying if you want some which are missing, you can propose, and they will review it and add them if there is a good reason for that. So
yeah. So for each data type in a session, they have 3 different kinds. You got public, private, and shareable. For the public, that is something that everybody may access. You got private, that is data like your body, weight, height, and so on. And shareable data, that is data that you choose to share with others.
Mm-hmm.
Yeah. Within the data types, you got data sources and data types and data points and data sets. So the data sources are the source of your sensors, raw data, basically. So you got different kinds of fitness data. So fitness data is what they call when they aggregate different kind of sensors to some predefined rule algorithm telling what kind of activity and what you did, what your performance was in that activity.
Mm-hmm.
Yeah. Data points are timestamp data for a data source. So a sensor or a step sensor might tell you this time you did this X amount of steps. And you got data sets, which are data points from a particular source in a time frame. For accessing data, it uses OAuth. Nothing special about that.
Mm-hmm.
You got 3 different kind of permission types. That is what I talked about the private and shareable data. So an app have to request the 3 kinds of data types, and the Google Fit API again decides when an app can access this kind of data. It doesn't always allow you to access it, like the location. It only accesses it when you're running using an app like Roadkeeper. And for the body, I think it's always for the activity is also connected to the app or the activity you're doing. And the session may be created, deleted, listed, or updated. Yeah, the created part is not for the user to decide; it's for the developer or the app. While the user may delete or list or update those data. This is an example, a screenshot of what is called Noom Coach. They use Google Fit. They also use HealthKit, but for Android they use Google Fit. And what is special about this app is that they combine your meal logins with your activities, so they're able to customize how much you're supposed to eat depending on your goal and your height and your activity and where you are, and tries to look for alternatives to depending on your location and how much you've eaten today or how much you walked today. So you can also have a look at the Google Fit dashboard. There isn't much data for me since I don't use Android. So this is the basic dashboard. Got your activity today, your statistics, and your calendar. There's nothing much to it. But using different kinds of apps, they can combine data, making it more sophisticated than the dashboard is actually showing.
Can you connect your iOS device to Google Fit? Or do they don't have a Google Fit app on the iOS?
App, but you're able to use web applications using the REST APIs. So, then real support for iOS. Yet, they say. So that was it.
So what do you guys, how would you compare the Google Fit with HealthKit? Which one you think is more powerful or better? They seem to be similarly, very similar, yeah.
The one major selling point they have is by using Google Fit, you're also integrating your data with the rest of their services, Google Cloud storage.
The HealthKit, everything is on your device.
That's the difference, yeah.
And here's everything. They have everything.
In the cloud,
yeah. You have everything. HealthKit.
Yeah, that's one of the things that I noticed, that everybody could access all the data, your fitness data, your logging, your meals, your activity, or your location through the Google Fit. They don't have any permission controls besides requesting it from the user. But on the developer side, they have some guidelines to how you should use it, and they're saying you shouldn't use the data to others, the other things than tracking their activities. But yeah, they don't have any real permission
enforcement.
No enforcement.
Right, but I can mark some of my data private, and then the apps can't access it, right?
Yeah, that's right.
Yeah.
But for a normal user, I think if the app were asking for permission, they would probably just let everything go through for the convenience.
Yeah. Yep. So, any ideas of what is missing or where this could go in the future? Like, what would you like to have more? What support would so permission system, that's one area which, like, fine-grained control over accessing the data or revoking access. What else can you think they could do, both companies? So in a sense, Google Fit is a little bit more like the research kit, where you're actually sharing the data and everybody can kind of do some analysis and something with the data, right? because ResearchKit is also public, like you submitting your data for other apps to process it. Whereas the HealthKit is more about privacy and just storing it on the local device.
The Google Fit also have an API or a usage node where they push data to the doctor.
Mm-hmm.
They share all the data with doctors, so the doctor is able to follow.
Yeah.
Are you following the recommended activity levels, and are you eating correctly?
Mm-hmm.
Yeah.
So what do you think? What would be a good thing to have?
An iOS app.
Yeah, but Apple has a policy of apps not competing with their core functionality. So they already have a health app, and that would kind of compete, so they can not let it through. But it would be nice, yeah, if you could use your iOS device to log.
You said you can use the RESTful, right?
Yeah.
Yeah.
So
It should be possible to have an app which.
you can use that.
Yeah.
In your own app.
Yeah.
Just like you could use the Google Cloud for RESTful and web services in Android.
So Apple didn't have any app on Android. Yeah, they have now one. 2 weeks ago, there was a first app for Android made by Apple.
Yeah, they want to copy your.
Yeah.
You can copy your Android data
to iPhone.
Very arrogant. I like it.
That's the only app they have.
Yeah. I saw that. Very arrogant. Ballsy.
Because Google has quite a lot of apps on iOS. They have Google Maps and Search, and most of the services they offer for iOS users as well. But Apple didn't offer anything, and now they offer one service migrating to iPhone. Yeah, so it's quite difficult. Like, one thing which those APIs offer is the unification. So before that, all the fitness tracking apps were storing stuff in proprietary formats, and there was no interchange between them. It was actually hard to migrate from one to the other. So the innovation was a little bit stale, right? Because I'm kind of locking your data in my own app, and then I'm kind of competing against everybody else's, fitness trackers. And that was a little bit less innovative environment for companies to kind of try to do useful things with your data. So now the data is sort of yours. You can expose it to different apps, and then if an app does something useful with it, it kind of is easier to migrate from one app to the other. So the innovation is sort of stimulated. They had this Google Fit open for developers for over a year or maybe longer, but you couldn't use the cloud services. You had to use like a local equivalent to test your apps, and now it's all launched and it's all working. So, well, we'll see. So that's as far as the Google Fit goes. And how about the cloud services? They again seem to be pretty similar to between Apple and Google.
If you used the cloud kit, the push notification, like I said, it will always be the last one. That if you can't get the push notification, it's always the last one
that gets through
to your device, so it will always override.
Right.
So it's always the last one. Be able to get them.
So do they have an ability to push to multiple devices of your ownership, or?
Probably.
Yeah.
At least you can subscribe, right? So if you have, of course, you have a different subscription for each device to that same data, same records. So yeah, it's device dependent.
And do they have some sort of command line support for, pushing data objects into storage or not?
Can't use the web service.
So in the browser.
Use curl in command line.
Yeah. Okay.
Not the framework.
Yeah.
So it's native web service, CloudKit, JS.
Mm-hmm. So what are the advantages of using? So advantages of using messaging services are quite obvious because yeah, you have the push notifications and you have the ability to broadcast some messages. But storage-wise, would you be rather using Apple Cloud Storage, Google Storage, or you could go with the Amazon S3, for example, as a storage solution?
I'm using the Amazon S3.
Yeah.
I haven't tried Google Cloud Storage. I like their web UI better.
Mm-hmm.
Do they have Node support, for instance?
Yes.
Yes, they have a framework for Node. I'll rather use this one because the Amazon is very shitty interface.
Yeah.
This looks better.
More convenient.
Yeah. That one looks much better, much simpler. The other one looks like internet from 1997.
Yes. So in terms of usability and kind of convenience, that's one argument. In terms of storing users' data, if you use Apple or Google and you have users having Google or Apple accounts, you can tap into their quotas somewhat as well, especially if you need to store some.
If you store it in the private database,
you
use the Apple their own cloud storage space.
Yeah.
The public is the apps quota.
Yeah, it's similar here. I mean, the Google Cloud integrates with Google Drive and so on, as you were saying. So you can easily migrate objects between the storages, and you can use the Google Drive API to use users' drive storage to store stuff in their drive instead of using it in your app cloud storage space. So there are some advantages of kind of reducing your costs in a sense. So if you want to offer some free apps, and your revenue model is based on advertising or something, then you don't want to be paying bills for people's images. You say, yeah, sure, you can take photos, but they are stored against your own quota of Google Drive.
People are used to that now, aren't they?
Who?
People are used to it now.
Yeah. Yeah.
You take a picture, it's your quota.
Yes.
The apps.
Yeah, I'm not sure how Facebook does it. They probably store it.
They have some content delivery network.
Yeah, they store it themselves. But with Google, yes, definitely your quota. If you're using Google Plus and you're taking lots of photos or videos, yeah, that counts against your own quota. And with Apple, it's the same. But yeah, Facebook needs to kind of catch up to be able to do that. Yeah, thank you very much. Sounds good. So yeah, please email me the slides, so I will put it on the fronter page. So who's next?
That will be me.
Okay. Should we have a short break?
I think so.
Okay, so let's have a short break and then we resume.
I became an expert in Google Cloud and Google.
Yeah.
Does this reach outlet somewhere?
You can go behind yourself. It might be closer.
Låse en kamera. Yeah, please. Those are locked. And not. You got the power or you want the extension?
I'm fine.
Yeah. Jeg fant en nettside nå forresten, som du kan selge ting på for å få riktig regnskap og sånn. Det var litt gode ting av det.
Fikk du noe mye til presentasjonen, Markus? Fikk du noe mye til presentasjonen?
Ja, han var litt utydelig. Joakim sitter rolig, litt dårlig med.
Dårlig, ja. Du burde jo klare den å stå på hodet nå i sted. Du skal få under bordet da.
Ja, riktig.
Da hadde det vært det beste å kunne lage et spill når du har skannet rommet. Og så liksom...
Ja, han får jævlig langt i å skanne rommet.
Jo.
Hadde vært fett å stille inn her.
Ja. Så hvis du har et tomt rom da, skal du ha banen inne i det sånn.
Du burde jo ha hatt sånn geolaser.
Geolaser? Ja, sånn det.
Det er sånn står.
Ja.
Sett der, altså skyter laser her, sånn flere tusen punkter her, og det er med 100, så da er det bare skanner rommet noen sekunder. For den er alle dette. Det er litt imponerende.
Ja, det er verst. Sikkert litt dyr enn det der.
Ja, det koster det.
Når det står på nasjonal statsbudsjett, liksom.
Prisen er jo en ting, men saken er jo at det er mulig. Det er så spennende.
Det er din take.
Har du hatt en server?
Yeah, I installed everything, and I imported the demo course. No, I just looked through it. It's not so complicated. It just it uses JavaScript
Typing.
and Ajax,
Typing.
and you just define some methods in the class. It's really fast.
But did you use Marcus's guide, or did you find out yourself?
No, I used his
Well,
because
no,
I
it's
was
okay.
halfway there because I didn't figure out that you can just delete the folder and clone
Like a Geo
the
Jason.
repo.
Okay.
So I was like trying to do it in more elegant way to define some variables or something like that. And Marcus just deleted and then cloned it.
So did you manage to
Yeah.
make everything?
Have you guys gotten it for her?
Marvelous, yeah. Kind of. You get an error before the export. It shows, but then when you want to edit it,
It's in Xbox SDK or inside of the open
Yeah, I didn't know you were asking.
yeah, because
Yeah, it's in the open.
okay, because you can just install, you can download SDK and install it inside of the SDK and use like localhost to access all the Xbox you have, and then you can deploy them inside of your. It's a strange system, but
It's a really strange, really complicated.
it works.
And you solved
It
the
works
first
now.
task.
It works now.
And you solved the first task.
Of course.
Nei. Ja, for det har vi liksom. 3 stykker glemt at vi hadde strømmøte i år. Bare, åja, var det i dag?
Jeg vil ha ikke gått opp halvtid etterpå. Skyld på det. Så blir det ikke alarm på bak.
Where? For det.
You said your alarm was going.
Yeah, because I don't know, there's something with the iOS 9.
Yeah, it actually is. I saw it.
Yeah,
That's
because it doesn't work.
Because I got mentioned it, I didn't deliver.
Hvis du går inn på oppdateringsdagen nå, så står det ny oppdatering, så står det alarmer og nedtellinger går ikke av innimellom.
Yeah, probably explain. But if you set 2
I
alarms,
gave a recipe for a good cake.
so if you set 2 alarms, the first works and the second one.
Oh.
And I set 2 because there was a lunar eclipse. Yeah, and I managed to wake up for a lunar eclipse. For the meeting.
So close.
Yeah.
Det er faktisk sant. Det står i der.
Du venter, så er det ikke. Jeg vet, nei, jeg er ikke så basic feil.
Det er noen så 2 alarmer for noen gang.
Det er idiotisk.
Og så hvordan har det skjedd? Hva er det du liksom har gjort? Hva er det du driver rett feil på for at det skal skje?
Ja, det betyr at en alarm går.
Ja, men det er jo sånn.
Ja, det er helt rart. Det skal ikke skje.
Fordi det er basert på lokale push-notifikasjoner, notifikasjoner på telefon, vil jeg tro.
Okay.
Og det er sånn, da går det er sånn event-handler, ikke sant? Eller den ligger i køen når ting skal skje.
Ja.
Så liksom, da skal den ringe, så skal den ringe i dag, så skal den ringe i dag, ikke sant?
Det blir aldri registrert. Hva er det du tror?
Det kan hende.
Kanskje hvis det først handler i køen.
Ikke så før en, liksom. Den hadde jo den der fantastiske go-to-feilen. Det var sånn der, de hadde if-løp. Derfor du bruker alltid brackets, når selv om du har en inne i if-en, I'm just saying. Men de hadde if med bare parentheses, og så stod det go-to en eller annen stand. Og så stod samme funksjonen en gang til rett etterpå med go-to. Så at den, selv om den ikke gikk inn der, som den egentlig skulle, så gikk den bare til neste, og gikk inn der uansett.
Ja. Skjønner.
Der var. Ja. Derfor alltid, uansett.
Ja, ja.
Uansett.
Det er lettere å se.
Ja, det er faen meg helt ubrukelig. Nei. Og det er når det blir det der dumme spørsmålstegnet, når det egentlig ikke er ikke en liksom. Det spør ikke. Det er bare sånn, det bare ser så dumt ut.
Ja,
jeg vet ikke om du kan lese den. Mapping. Hvor var det Bjørn? Bjørn hjelper deg, vet du, det er noe du lurer på. Bjørn, ja. Det er morsomt, det er han er familien, vet du. Jeg tenkte at jeg var en feil med bokene. Det sender seg Bjørn, så du ser på den. Ja. Bare hvis du gjør feil, så skriver du tilbake. Prøv denne 300-stein, liksom. Da hadde han vært inne og rettet annet. Det var han så klar at det funket.
We haven't decided the date of the exam. Because it's the same day as this.
Okay. Yeah, I haven't changed it yet.
We are changing the exam.
So, yeah, what did we decide?
After the weekend.
So Runa said that he didn't want to change the seminar date. So
No,
we have to change the exam date.
Exam. Okay. 3 Finnish students are talking about it.
So we have to change the exam date, right? Yeah, let's do it now. Otherwise, I forget again.
So after the weekend, then?
No, then we have game.
Which date is
It shouldn't be this late. It's on the
So currently the exam is on 15th,
Yes.
and you want the exam to be when?
Yeah, okay.
That's
I can live with that.
Wait, that's the delivery of the report.
Yeah, 13 is the delivery of the report, and I have to read reports before we meet.
Yeah.
So
The second, then.
it would have to be.
The second is
Yeah, you said you
just
have
one
games.
day from
Yeah, so
Do you have a longer?
how are you supposed to prepare for
Behind
this
you.
anyways?
Oh, you need a longer cable?
Yeah, it's just.
It will work.
Yeah.
Yeah. You see, it's perfect.
Yeah, perfect.
It's perfect size.
Yeah,
If you go a little bit this way, then because otherwise your head is in front of the monitor. So just a little bit. Yeah, perfect. Thanks. So what's the consensus when the exam should happen?
Maybe 16.
22nd, you say?
Yeah, that's a good idea.
I can afford to do that after 21st. Am I getting 21st?
So 22nd is it, right? 9 o'clock.
I can do 22nd.
But you can do it on the game exam day. Because you said someone could do it on the game exam.
Yeah, you can do it on 21st. Yeah. So you either do it on 21st or 22nd.
Is it the 20th, the game exam?
Yeah.
Okay.
Okay, 20 then.
Yes. No pressure, not on the
23rd.
When are you?
Can you do
15th.
23rd?
Yes.
Okay, 23rd. It's just postpone it.
No, 23rd. I cannot do 23rd.
Yeah, we don't need you.
But what day is it?
Yeah, we can do it thoroughly, right? That's why I think it is very well this year.
It's too close to the day. Just one day in between.
Yeah, that's like every semester here. It's one day between every exam. When do we have them?
well.
We have to do the report.
Not connecting?
It usually works after I do the troubleshooting thing.
There is a network cable below. Is it longer than the one you're using?
No, it's fine. It's just because I use this computer as a wireless router at home.
I see. Okay.
I need to reconfigure.
Det er litt trangt med telefonen. Jeg ligger rundt og liksom. Ja, det. Ja, det er det samme. Det er livsretten her nå. Nei, men oi, faen. Ikke bare, men jeg kjøpte 3 grunner kyllinger i år. Hun la meg, jeg skal ha 3 kyllinger, så jeg går, så nei, kyllinger, så. The girl asked me, do you mean thighs? No, chickens. Chicken.
Okay, so just give me a second. I just email about the exam. So 22nd, 9 o'clock.
When we deliver the report.
Yeah, so the reports now can go till 15th. You can have an extra few days.
Yeah. That's nice because we have web until 12. and reports before that. Man er god ute på oss. Sånne tema og ideer og ja, 7. er 12. Det står 7. Ja, det er jo så siden 8. Sent. I årene på måten. Fem sånne her artikler og ja. 5 now. So there's about that 15 or something for the sources. And for the sources for the report. So we're doing a survey. Yeah. How's the report in this course going to be? For us to make something and not 3 papers?
So if you've made something, then you report of what you've made, and you showcase how certain things were achieved and how certain things work. So your report will be a technical report. If you research something, then it will be kind of more a research report. Because yeah, I mean that's what we decided at the beginning, that some topics are more technical and technology oriented, and that's okay.
Someone has to try it, right? And then explain how it works. That's all already did that, probably. You can find anything on cloud.
If you can find it, then that's, you use it as a source, that's fine. Okay, so we ready? I will shift the spotlight on that side.
So, yeah, I'm going to be talking about augmented reality. A little bit in general, and some of the genesis of AR, the technology that's used today, and some of the upcoming devices that is the cutting edge of the technology. So what is augmented reality? Augmented reality is the augmentation of elements in the real world with digital information using some sort of technology. One could say that you are augmenting your senses in a way. Usually the visual or the auditory, but not necessarily limited to this. In other words, AR is a technology that allows you to see things that are not there, hear things that are not there, possibly even smell or taste or touch these things with the proper technology. All without being insane or on drugs or anything like that. Augmented reality adds to our experience of the physical world, as opposed to virtual reality, for example, which replaces it with a completely virtual experience. So before I talk about the different augmented reality technologies, let's take a brief look at the genesis of AR to better appreciate where we are today. So when I looked into the history of augmented reality, I found that a lot of people trace the genesis of AR back to the Sensorama, which was a machine built by Morten Leonard Heilig in 1962. There's also a graphical processing module that processes the graphics that is going to be overlaid over the real-world visuals, and a display that mixes all of this together for the user. If you look at this different display technologies, there are 3 different kinds of AR systems. You have monitor-based approach that uses a camera that's hooked up to a tracking system that gives positioning data to on the camera, a scene generator which adds the virtual objects, and a component to combine the real-world video with the virtual content. This is then displayed on a monitor for the user. There are also handheld devices that can handle AR systems, like our phones or tablets, with a multitude of sensors. Yeah.
Marius?
Yep.
The stream is down, I think.
Yeah, I was fixing it. It should be up now. Yeah.
Yeah. And lastly, there are the see-through HMDs, which is the big technology. It contains all the see-through head-mounted displays, of course. Contains all the main components of an AR system, but they are worn on the head, allowing the user to move as they will, with their hands free to do whatever they want. There are currently 2 different types of see-through head-mounted displays. This picture shows the optical see-through head-mounted display, and it shows the general architecture. As you can see, all the main components of AR is present. There's a video camera that, while not strictly necessary in this specific system, can help with tracking to track key points in the scene. A head tracker, a graphical processing unit, and a display in the form of a projector and your own eyes. This part, the optical combiner, is a partially see-through material that's also partially reflected. So it allows the virtual object to be superimposed over the real object, the real world. This is the video see-through HMD, which is the second kind of see-through head-mounted display. It is much of the same, because in the head tracker, the graphical, the scene generator, which is the graphical module, a video compositor that composes the captured image from the video camera, and then it's displayed on a monitor for the user. Arguably the most important part of an AR system is the tracking. Tracking the position of the user and objects in 3D space is an incredibly important part of any AR system. And there are multiple ways to this. You can use marker and markerless based vision tracking. In marker-based tracking, it involves using a unique marker of some kind, which is then found in the video using a thresholding function to separate to find the specific image that's on the marker. The XYZ position of the marker is then found, and the virtual object is then placed on top of this marker. This can be quite annoying if you're just using it for fun. You do need to do the extra step of setting up all the stuff. But it's also used in tangible AR, where you can move around the objects by moving around a real physical counterpart. Markerless tracking involves identifying key points in an image. This is obviously a much more complex task. It involves usually edge detection or blob detection to figure out to find key points in the the scene that can be traced when the camera is, or tracked when the camera is moving. There's also sensor-based tracking, which is the most general. You have GPS tracking, optical sensors, as I said, and the inertial sensors, like gyroscope, accelerometer, and magnetometer. There are also hybrid solutions using both of these kinds of tracking if you need more specific needs. One of the current or the upcoming technologies that got quite a bit of publicity is the Google Glass, of course. This is an optical see-through HMD, but it's not really not having the full view of the world. You only have this tiny piece that you actually see anything through. Would any of you consider using the Google Glass if it became like a public thing? I don't know. I think if it's useful enough, like if it's more than just a fancy watch that you can glance at times, it could probably take off. But at the time, it's still not no release date or anything. Apparently, the lead designer of Google Glass said that it's going to be released when it's perfect, and that's it. That's all we know. So,
which is never, right?
Yeah, exactly.
Be able to show the context of where ads.
Here you can see how.
Here is the equivalent of the see-through head-mounted display.
Yeah.
Here
you can see how it works in the Google Glass. You have the projector that projects on the combining prism, which is see-through and reflective, the same as I explained earlier.
Mm.
One other of the upcoming big technologies are, of course, the Microsoft HoloLens. This is also, it was very difficult to find more specs about this outside of what's already on like Wikipedia or something. But what we do know is that it has a lot of sensors, a very good depth camera, lots of cameras, inertial measurement units, also high-end, very high-end CPU and GPU, as well as what Microsoft is calling an HPU, which they created in-house, holographic processing units. I don't really know much about it outside of that, but it's going to be very expensive. It was said that it was going to cost a lot more than a new gaming console, for example. So it's not going to be, once it's released, it's not going to be like anyone can buy it, because it's going to be expensive. And the lenses the Google Glass. It has 3 layers, blue, green, and red, each which diffractive features, and a light engine, whatever that is. I couldn't find really much on it. That basically shoots the light into the lenses that reflects around until it hits the eye. Let's just look at a video to show how it's supposed to work. So they're using a camera.
Can you put full screen?
Yeah. So they're using a specific camera that captures the 3D room that the HoloLens is also seeing.
For example, planning a trip to Hawaii in a couple weeks, so I placed this awesome weather app over here. So when I'm moving around, I can easily glance at it, reference it, and understand what the weather's going to be like when I get there. Hopefully still hot. Then if I look up here on the wall, wherever I go in my house, my entertainment tags along. All right. And where it gets where I'm going, I simply place it, and I can scale it as big as I want.
It's only using specific hand gestures. It's the tapping and the grabbing.
That's not something just a video player does. Every single universal Windows app has the same capability. For example, I place a calendar over here because, as Alex will tell you, I'm late for pretty much every meeting. So this makes it, a guy like me, makes it a lot easier for me to just check in and see what I've got coming up next. We're discovering uses for holograms every day. We know with all you here at Bill putting in lots towards it, we're going to be discovering new uses every second. I hope you have an inspiring time at Bill. We'll see you out there. Thank you. Beyond what is possible, what's today's state of the art? Take it away. Thanks, Alex. Today we use a combination of cadavers and medical illustrations to teach students anatomy. It's a curriculum that hasn't drastically changed in over 100 years because there simply hasn't been another way.
But what needs to be kept in mind as you're seeing this is that the field of view of the HoloLens is not 180 degrees or more. It's actually like 40. So you only see really a piece like this, and that's the kind of like if you've tried.
Yeah, so you can try those.
It's the same kind of thing that you only see the small square, and that's where the
augmentation happens.
Yeah, exactly. Okay, my computer's dying, so let's stop there now. It's overheating. It can't handle 2 screens at once properly, especially with a video. But yeah, you get a small idea of how it works. It's not. That's of course a very ideal situation. It's a stage show. They've set it up so it works perfectly every time, of course. But I think it still has a lot of potential, and it could be really cool. The future for AR, in my opinion, is smaller, more lightweight devices that hopefully will just look like regular glasses someday, ubiquitous to everywhere. People will just use them, and it will be part of life, with of course a bigger FOV, not just a small square. There are of course some ethical concerns with having everyone having a device on them that always records all the time some form of video. Difficult to see what will happen in the future with that. For example, if you see in the future that the AR glasses is integrated into normal glasses, and say you ban the use of these kind of devices in like gym lockers or at cinema or whatever, there's people who have bad eyesight. Will they just get locked out, or what? How will they handle that? Yeah. It's interesting to think about at the very least. Yeah, that's all I got. Thanks for listening.
Thank you. So what do you guys think? Pervasive video recording. We had that discussion last semester, I think, and it is technologically a possibility. It didn't really started yet, mostly because of 2 reasons. One reason is storage. So if you're continuously recording video of your life, it crank up quite a bit of disk space occupying. The other one is, okay, you have, let's say, a recording of your life from last week, so many gigabytes, and then what? You know, what you're gonna do with it?
So it's pointless.
It's kind of, we don't know what to do with it. Like, you could search it. You could search, oh yeah, did we agree on the exam on this day or this day? Like, we could roll back a week ago and review the discussion, but it's still time consuming.
Yeah, but you don't have to store a video of that.
No, you don't.
Make some algorithm that will extract data from there.
That's right. Yeah.
Or
just pick the one something you want.
Some samples, yeah. So this technology doesn't exist yet. So the technology to kind of pick and make a summary. So okay, I can record 24 hours of my life today, but I'm never gonna review that 24 hours because I would need 24 hours to review that 24 hours, right? So maybe a 30-second summary would be good to have from a day, but we don't know how to do it well. There is research work going on into video summaries and so on, but this technology sort of doesn't exist yet. So the technology to record everything, yes, that's already available, and that's been available for a few years. But making kind of meaningful, some meaning out of that, that's where the challenge is. Would you object if somebody is wearing a device which records everything you say and everything you do all the time? You would object? Why?
It can be used in like blackmail, no, serious blackmail. If you say something that meant to be out of the room, right? You're having fun or something. Someone could be an asshole and try to use it against you for some reason, right?
Yeah.
But you won't mess around with people who.
No, but if you're at a party then, let's say, and you say something like, "Yeah, get me some ass," right? And then your girlfriend is there. And then your asshole friend can just say, "Yeah, I want to date your girlfriend," right? And then he shows that, and you said that you should date me, right? Not complicated. Not CIA.
A very simple, down-to-earth example. Yep.
Common in Norway at least. Could happen. It could be cool to use it for some crowdsourcing type of, let's say, some eyewitness thing.
Yeah,
right?
Exactly. Yeah.
So if you have timestamps for videos and you know these people were around there at that time, right?
Yeah.
See those, extract time from timestamps.
That's right. All right. So how about the augmented reality? Did you try those glasses? Those Meta glasses? They kind of work similar way as the Google Glass. They also have the prism and they have a projector, and they kind of, but Google Glass only has one, right? So you have a one tiny screen on one of the eyes. It actually is above your eye, and the screen is actually very tiny. So it kind of floats around here, and it's quite tiny. It's sort of you can display more on this watch than you can display on that screen here. So really, you can kind of display only one thing and sort of one word if you want to be able to read it. So it has a very limited resolution and very limited kind of capabilities. So it's not as great as some of the videos of Google Glass kind of depict. It has the camera, and interestingly enough, it has another camera looking into your eye too. So you can, as a developer, you can see when a person blinks, for example, right? Or whether the pupil kind of dilates or whatever, because they were thinking of maybe using that camera as a kind of UI, as an interface for you to control the Google Glass. So it opens up some interesting possibilities, because you could, for example, get a heart rate from that camera looking into your eye as well, right? It has a camera facing out. It can continuously record everything, but it kind of goes to Google, and then you can get it out. But it doesn't store it locally because of the space limitations. So there are some challenges. And as you were saying, there are places where they kind of don't allow continuous video recording. So it was sort of
movie theaters, that might not be very popular.
Yeah. So the augmented reality technology kind of is getting there. We're getting kind of a more miniaturized devices, and the Google Tango is one of the examples of tracking done well. The tracking on this one should be good, but it's not that good, and especially the depth perception, like on the video they're showing, well, you just click in the air click on the buttons, but you know, try this demos here, and it's like, okay, where is the button? Doesn't want to click. So it doesn't really work that seamlessly yet. So there are some technological, and research, opportunities.
But I'm wondering if the HoloLens has some algorithms with hands in front of your face. How it handles that? Do you see the stuff right there, or?
I mean, you see your hand, right?
Yeah, but do you see like the object like plastered on top of your hand if you hold it in front of you, or does it have good? Especially if you move your hand fast, does it keep up?
It's hard to say. Yeah, it's hard to say, but I suspect it's not too great. So judging from this prototype, for example, I was a little bit disappointed. Like they make quite a huge hype about it, but it actually is quite early in that arena. With the head-mounted displays for virtual reality, they make huge progress. So tracking this, as with Project Tango, is very accurate and it's very reliable. And then the data feeds are fast enough for the high-resolution rendering. So that there has been a huge progress with that, but the see-through ones are still somewhat problematic. So we may need to do some work, right? It's not all kind of solved yet. And then the use cases, like what is the best use case for technology like that? So if you just play a little bit with the Tango tablet, you sort of realize some things are kind of great with this device, but for some things it's not that great, right? And we often don't know it until people actually try things out. So yeah, and how you interact with the see-through augmented reality, you would like to interact with objects using your actual hands. You don't want to have some sort of a virtual limbs or virtual things, because that's more natural to when you kind of see through, to use your hands and your own body and your own gestures. With the augmented, with the virtual reality, it's okay if you have some controllers attached to your limbs and you actually see something else in the virtual world. So you can kind of simulate that, your hands look differently and you're kind of controlling those other type of limbs or control mechanisms. But yeah, it is quite an open.
The technology is still quite young, I'd say. So it's a lot of development left.
Yeah, that's right.
Interesting to follow.
It is interesting, yeah. So yeah, watches is another kind of spectrum. So I was just reading, like with the gestures, you have kind of gestures for scrolling on the watch. Yeah, that's kind of cool because you can use accelerometer to have wrist-specific gestures for rotating the screen and doing kind of stuff with it. It's the same with the augmented and virtual reality. I'm not sure if the HoloLens has the Kinect chip built in for the depth perception.
I don't know if anyone knows.
They try to not tell too much about it, but if it does, then it possibly might have some tracking capabilities similar to the Project Tango device, right?
At least.
Yeah, but as you say, the field of view is quite narrow, and especially here as well. It is actually quite annoying because you
end up moving your head a lot.
Exactly, yeah. And the augmentation only happens kind of in a very narrow field of view, just in front of you. So yeah, here you have two modes of operation. You can either have a normal field of view like you normally have, plus the augmentation in the middle, or you can narrow the field of view only to the place where the augmentation happens. So then you kind of see a little bit like that, and then you have to kind of keep rotating. Yeah. Okay. So what do you guys think? Will this technology take over? Will we have, you know, Tango tablets? All tablets will be Tango tablets?
Looks like that.
Yeah, possibly.
As the technology gets cheaper and more easily integrated into the existing hardware, I don't see why not.
All right, so one question for the other two speakers about the cloud storage. Do they have any provisions about you encrypting the data? Or can you encrypt the data yourself? Or do they have some sort of ways of you?
There is something. If you have, when you submit that, they ask you, are you using
Encryption.
some form of encryption that is not something? So you probably shouldn't. Yeah, they probably are encrypting. So I think it's based on the rest or the web services.
Yeah.
At least native. So.
Yeah, so that at least two or three kind of aspects to that. So one is if you're encrypting the data, let's say you're encrypting your Google Fit data, they can't really harvest it, right? So you're using the storage, but nobody can really access it. And then you kind of locked it. So they may not like it. The second one is if you're encrypting the data, then it's harder for them to do the partial updates. So as you were saying, if I uploaded part of it and now I'm loading another part, if the file was encrypted, then you may not be able to tell, you know, you may have to have a smart way of doing that compared to the normal non-encrypted data, because the encrypted data looks like noise. It looks like random everywhere. So it's harder to see how you can merge the chunks. So for example, that was the problem with early versions of the cloud storage on Google Drive on Dropbox, because if you had a big random file and you did some update, they have to make a diff and have to change what has changed. But with the random files, often everything changes. So let's say you have 5 gig file, then suddenly you have to keep updating 5 gig every time you do a small change. So the encryption kind of makes it challenging for the bandwidth and challenging for the making sure that your snapshots are kind of correct. And then the third reason is the legal. So there are some provisions in US for using certain types of encryption and so on. Europe is slightly different, but in US you are not allowed to use too strong encryption, with the hope that the government can decrypt it if they need to. Yeah.
What is the standard? The standard algorithm for encryption?
AES?
AES?
Yeah. But they were limiting what was the key size. So stronger keys were not allowed. Only the weaker keys were allowed. So yeah, so that's kind of an interesting take on the storage. Right. So that concludes this lecture for today. Normally the game class starts at 12 or at 1? 1 o'clock. Yeah. And we have some speakers today? Okay, excellent. So we will reconvene at 1 o'clock then. Thanks.
You doing the game course today?
I'm doing the game course because Simon is in Trondheim.
Yeah.